Hello, everybody. Welcome to today's webcast, Here Come the Data. We're happy to have you here. Today's session is offered jointly from the Society for Scholarly Publishing and the Charleston Conference. Really excited about today's session. My name is Leah Hines. I'm the Executive Director of the Charleston Conference, and just a few words of welcome and housekeeping before we get started with the session today. If you've never used Zoom before, hopefully you found it easy to connect. There's a few notes here about your audio. If you're using your computer speakers, your computer audio, you're going to get the best quality sound. If you're having problems with that, however, there's information on how to call in and use your phone, your telephone audio. And I'll be available for questions if you have any technical issues. You can throw that up in the attendee chat. Speaking of the attendee chat, while I'm going through a few more announcements, if you'd like to let us know your name and maybe your role and institution where you're joining us from, we'd love to see you and be able to say hello. So you can put that in the chat also. Be looking forward to hearing from you and seeing who's joining us today. So at the bottom of the screen, you'll see three icons: chat, raise hand, or Q&A. We probably will not use the raise or lower hand. Some of our presenters may ask a question and say you can raise your hand if you've experienced this or if you have, this resonates with you. Mostly what we're going to be using though is the one next to it, the Q&A button. So we're going to hold questions and discussion for the end for all of our presenters. So if you have a question during their presentation, you want to ask before it leaves your mind, you don't have to worry about asking later on. Put your question here, type in your questions and comments and hit send, and we'll hold that until the very end of the presentation. The session is being recorded today, and we'll put a video recording up on the Charleston Conference website just within a couple of days. We'll also link the slides as well as contact information for our presenters. So with that, I'm going to introduce our moderator for today's session. We are being joined by Jeff Lang. He is the Assistant Director for Platform Development in the American Chemical Society's Digital Strategy Department, where he supports innovation and product development that explores the untapped potential of technology to enhance scholarship. Jeff has degrees in computer science and information management, and he has spent the last 15 years at the nexus of technology and academic publishing services. So thank you so much for joining us today, Jeff, and for moderating the session. He's going to introduce our speakers and take it from here. I will mute myself and turn the video off, but I will be here again, like I said, to answer questions in the chat. Thank you very much. Take it away, Jeff.
Thank you so much, Leah, and thank you all for joining today. The session is going to talk a lot about how being a scholar today often means distilling volumes of data down not just to the conclusions of your research, but to Microsoft Office-sized chunks that can be distributed along with your research paper. But we're now entering a new era, the data epoch, when all of that is changing. Data is becoming a first-class citizen, but the change has an impact on all stages of the workflow, from initial research through to eventual publication. That's what we'll be discussing today. We will use the terms data publishing and data sharing interchangeably during the discussion, just so you're all aware. And now I'd like to introduce our panel, who will give short presentations, followed by a discussion with your input. First up will be Ian Bruno, who has been involved in areas of chemical information and crystallographic data for the best part of 3 decades. He's currently head of strategic partnerships at the Cambridge Crystallographic Data Center, and is an active participant in a number of global research data initiatives. Tumai Christian is the Assistant Director for Archives at the Odum Institute for Research and Social Science at the University of North Carolina at Chapel Hill. She's responsible for day-to-day operations of the Odum Institute Data Archive, as well as establishing and enforcing policies in accordance with archival data standards and best practices. Tumai received her MS in Information Science with a concentration in Archives and Records Management, and is currently pursuing a PhD in Information and Library Science from the University of North Carolina. And Ariel Deardorff is the Data Services Librarian at the University of California, San Francisco. In her role, she teaches classes and does research on data management, open science, and reproducibility in the health sciences. And now, Ian, if you could get us started.
Okay, I will just see if I can share my screen, which, aha. Okay, hopefully you can see my first slide.
There you are.
Excellent. And thank you very much for this opportunity to participate in this webinar and to share some of the story about how the crystallographic community has been publishing and sharing data over quite a number of years. I want to say a little bit to start off with about the Cambridge Crystallographic Data Centre where I work. We originated more than 50 years ago in 1965. We're a financially self-supporting not-for-profit institution based in the UK. Our mission is to advance structural science and particularly doing this through providing high quality data, information services and software. And that summarizes a lot of the activities that go on at the CCDC. There's a focus on data, there's a software development effort to build tools that take advantage of that data. We engage in research and education and outreach. But at the heart of what we do is the Cambridge Structural Database. This now contains over 1 million small molecule organic and metal organic crystal structures. I'll say a little bit more about what a crystal structure is later on, but you'll see an example on the slide there of an entry from our database. We have links to over 490,000 articles in over 1,500 journals from, we think, more than 200 publishers. There are more than 400,000 distinct authors who have contributed to the data that are in the database. And we have to deal with over 80,000 data sets that are deposited with us by the community annually. A key part of what we do is to enrich and annotate those data sets. And this is particularly important to enable the access to the data, but also reuse of the data, but importantly, the knowledge. This is an example of a crystal. It's one that you may be familiar with, sucrose or sugar. And the data we get is the result of people doing experimental analyses of crystals such as these. From these, they derive a three-dimensional model of where atoms appear in a molecule and how those molecules interact. But fundamentally, what's being deposited with us are these tables of coordinates that you can see on the right-hand side here. But it's not just about collecting the data for its own sake. And the database was established in 1965, drawing on the vision of crystallographer and polymath J.D. Bernal, who believed that if you collected together lots and lots of data, then you could derive knowledge that actually transcends the results of those individual experiments. And it was with a passionate belief in that idea that the CCDC was established in 1965 by Olga Kennard, our founding executive director. Now, it's always difficult to know quite how to prove whether or not this is successful, and that would probably take another 40-minute presentation or so. So I'm just going to draw on some of the areas of application that were highlighted in an article that was published recently to recognize our passing of 1 million crystal structures. The data in the CSD can be used to derive knowledge about the shape of molecules, how they interact, but that can be applied to help people design drugs and manufacture those drugs as well. But it goes beyond drugs, and there's a lot of industrial areas that you see there where crystal structure data has the potential to help inform the development of new materials, whether it be energetic materials, semiconductors, catalysts, and the like. I want to say a little bit now, though, about what actually makes this happen behind the scenes. Some of the components that have sort of driven us to this point. And number one amongst these is the adoption of standard file formats. Now, crystallography is blessed with a standard file format that was developed by members of the community called the Crystallographic Information File. And this file captures the results of the experiment, in particular the coordinates of the atoms that we're trying to derive and the data that underpins that. But more than that, it's capturing metadata that describes that experiment, details of the sample, the equipment that was used, the conditions, also the software packages and the parameters. And this has been absolutely key to allowing the reliable interchange and exchange of data when it comes to making this available publicly. Once we have the data, it's important that there's a degree of validation that goes on, and we have a service called CheckSIF that has been supported by the International Union of Crystallography and was also sponsored by various publishers there. And what this allows the researcher to do is take the results of their experiment, upload it, and get a report. And that report is going to tell them whether there might be problems with that data. And the important thing here is not necessarily to sort of like say you can't publish it if it's the problems, but it's to get the research to explain why there might be problems or maybe go away and resolve them. And the final thing I just want to highlight is the importance of collaboration between repositories and publishers. We've worked over the years to develop relationships with a number of publishers, and through those we've come up with workflows that we hope make it easy for researchers to deposit their data in the first place, but then also make that data available alongside an article when it gets published. And I think a commitment by both repositories and journal publishers to adopting standards and encouraging the wider community to do that is quite key to making these workflows work. Something that's important behind the scenes here is the use of standard identifiers. We take advantage of digital object identifiers for both our data, and we're also using digital object identifiers for articles as well, and feeding those into an initiative called Scalix, which some of you may have heard of, which is all about making it easy to link data and articles together. We're obviously looking at how we can take advantage of ORCID IDs, and for those that might be interested in identifiers about organizations, there's a new initiative called RAW, which is aiming to tackle that. But we also have standard identifiers that are used in the chemical community. And whereas the sort of generic identifiers allow CCDC to connect to sort of generic resources such as journal articles and databases such as the Data Citation Index, INCHI allows us to make connections from the crystallographic world to the chemical world, where people might be able to find additional information about drug properties or pesticide properties and the like. Something I just wanted to draw attention to here is the fair data principles, which some of you may be aware of. But I think if you look at sort of the facets of the fair data principles, a lot of things I've touched on there sort of feature through this. And so the use of standard formats, the use of identifiers, the importance of having metadata, the role of data repositories, all these sort of things, help make sure that when data does get made publicly available, it is made available in a way that can be usefully reused. And this draws me on to some concluding thoughts. I think it's important that publication of data is important for supporting the peer review and reproducibility of published work. We try to make sure that our data is available pre-publication so people can assess the articles that's being written. Collective sharing of that data within a domain allows generation of insights that can be applied in other domains more broadly. And file formats and standard identifiers are key to sort of enabling that. It's important that publishers and repositories work together to sort of reduce the barriers so this isn't hard work for the authors and researchers. And paying attention to the fair data principles can really help sort of like understand what might be required to effectively share data. And the final note that I want to make is something I haven't really talked much about here, but it's the importance of sort of curation by domain repositories, because that actually is one of the key things that helps ensure that data and knowledge that's produced today will be reusable in the future. And that's my presentation.
Great, thank you so much. And for folks in the audience, now is a great time to go ahead and put in some of your questions. We'll queue them up for discussion later as we hand over to Tumai for your presentation.
All right. I think this is the concluding thoughts were a very nice segue into what I'm going to talk about today, which is implementation and enforcement of journal-based data policies. Can everyone see that?
Yes.
Great. So speaking of domain repositories working with publishers, that's something that we've been doing, specifically in the social sciences and political science. At the UW Institute, just to give you a little background of who we are and why this works, we've been around since 1924 as one of the oldest interdisciplinary social science institutes in the United States. And so we have quite a bit of domain knowledge and statistics expertise. In 1965, we also established a trustworthy digital data repository. So we do have our own collections of social science data sets. And also we have been committed to research transparency and openness. The late Tom Carsey, who was our former director, really championed this, and he was involved in the Data Access and Research Transparency Initiative in the political sciences. So bringing those things together, we were approached by the American Journal of Political Science, who wanted us to help them refine their data policy and also create a mechanism for enforcing their policy. So the editor at the time, William Jacoby, issued a new policy that required authors not only to submit their data sets underlying their the results of their articles into a designated repository, but he also wanted to add a third-party verification of those materials to confirm that they do in fact reproduce the analytic results reported in the article. So that policy has been in place since 2015, and we've been working on them to perform that independent verification of those materials. So just to give you an idea of how that works, when the authors submit their articles, and the articles go through the regular peer review process. If the article is accepted, it's considered conditionally accepted, at which point the authors are prompted to submit their data, code, and other materials to the repository, which then we retrieve at the Odom Institute to perform our data curation and verification. And I'm purposeful with the use of curation and verification, those two different things. If it doesn't work, we have to go through this, and I'll tell you more about that. We do have to go through this iterative process. So if it doesn't pass curation and verification, then the authors are prompted to resubmit corrected materials. So the things that we're looking for data curation, these are our archivists going through the materials. They're reviewing it, make sure everything is there. If there are any confidentiality, copyright issues, looking for any missing variable definitions. A lot of times we have issues with codebooks that are non-existent or they're incomplete. Also looking at file formats. If there are doc files that we receive, we want those to be in PDF, for example, and also enhancing that descriptive metadata. Once we've gone through that process, we then send it along to our verifiers. Our verifiers are some of our statisticians and students here at the Odom Institute, PhD students, and they receive the materials. They set the computational environment based on the description provided by the author. They reviewed the code to make sure that it is understandable, making sure that there are comments and commands, everything is there to reproduce the results. They compile and execute the code. If there are any errors, they record those for the author to then make those corrections, and then they compare the outputs to those that are reported in the manuscript. And so it's there's a lot of work that goes into this process, and more times than not, the materials are sent back. I just took a look at the numbers, and I think out of about 200 manuscripts that we have performed the curation on for AJPS, 10 of them did not require a resubmission. So all others have. So once they finally pass the curation and verification process, then the article is considered accepted, at which case the article is sent along for publication, and then we also publish the data sets in our case, Dataverse. And AJPS also puts the Center for Open Science badges, the Open Data and Open Materials badge on the publication, and also that happens on the data set, in the data set record. So like I said, most of them do have to go through the process, and authors do need to resubmit their materials. Right now we're at an average of 2.11 submissions, so resubmissions, so that's beyond the initial. So basically the materials are going through 3 rounds of this verification. For each manuscript, it takes about 6 workflow hours. A lot of the issues that we have, we're seeing some patterns, some of our struggles. One of them is the system independence, and that is that we have a different working computing workstation than the author did. So we have to match those things up because any variations preclude any guarantee of computational reproducibility. Also, this is a largely manual process. There's lots of different moving parts and systems we have to, through our communications and forms that we use. And so there's a lot of coordination that has to happen to avoid workflow delays. So the managing editor is key in this process. And then, of course, the major issue is that we do just get materials that do not meet the standard. And so that extends the amount of time and effort required for verification each time we have to send it back to the author. So some of the things we're trying to do to address these issues is working on some research and development in the space. We have been studying the effectiveness of journal-based data policies. Are the policies communicating what authors need to understand to comply with the policy? One thing we learned early on when the policy was first issued, that we needed more guidance to offer the authors. So there's more documentation, there are checklists for the authors. Also, we want to know what's affecting data policy compliance. So we have 5 years worth of data from the reports that we put together on all the errors that come up. So we're running analysis on that right now. Also looking at what training is available. And we also receive funding to produce some tools to streamline this process, to make it more efficient and hopefully more sustainable and scalable. And then otherwise, because we have so many issues, the education and training is one of our priorities at this point. We want to offer the foundational coding and data skills for computational reproducibility. So how do you automate your research workflows, documenting data and code, organizing things, packaging the research the artifacts for dissemination. So we've been busy, but we're hoping that we can come up with these tools and strategies for streamlining this because we need more people doing it. We're getting more demand from journals for the service, but it requires a lot of time and effort. Thank you.
Fantastic. And again, if you have any questions as a result here, you can go ahead and put them in the Q&A, and then we'll be handing over to Ariel next.
All right. Just sharing my screen now. Can you see my screen?
I can.
Awesome. So hi, everyone. This is Ariel Deardorff. I'm at the University of California, San Francisco Library. And I'm just going to be sharing a little bit about my experience working with researchers on data publishing in a library setting. So, oops. Okay. Now my slides are being funny. Let's try this. All right. So a little bit about me. I am a data services librarian, and because I'm at the University of California, San Francisco, I do have a perspective from a biomedical research institution. So here at UCSF, we don't have any undergrads, we don't have any humanities or social science researchers, so that's kind of the perspective that I'm bringing today. I'm also an open science researcher myself, so I have experience sharing my own data for publication. No, oh my goodness, sorry guys. There we go. All right, so I wanted to set the stage a little bit. This is kind of how I picture the ideal scenario in interacting with researchers. I'm sitting in my office and I get a call from a faculty member and they say, hi, I'm a faculty member starting a new research project. What should I do now to plan for data publishing? So this would be really exciting because as you've seen in the first couple presentations, there is a lot of work that goes into this, and the more in advance we can do this, the better. However, that's not usually what these conversations look like. They tend to be a little bit more like this. Hi, I'm submitting an article to PLOS One. It says something about data sharing. What does that mean and how do I do it ASAP? So as you can understand, that's a little bit more frustrating because it does require us to do a lot of work really fast. So what's going on here? So in my experience at UCSF and many of the places that I've worked and talked with folks, many researchers are still not really familiar with data publishing, or if they've heard of these requirements, they don't really know how to comply with them. So I wanted to unpack just a little bit those barriers. What do those look like and what are libraries doing? So first of all, we've been using this term data publishing, also data sharing, and I do find actually both of those terms a little bit confusing for researchers. So, many researchers, when they think of publishing, they think, okay, we're talking about articles. So it's a little difficult to talk about, okay, we're actually talking about your data at this point. And sometimes when we say data sharing, that has other connotations as well. So researchers will think of data sharing in terms of, yeah, I share my data. I work with colleagues in a lab. We share data all the time. Or universities often think of data sharing in terms of like intellectual property. How am I sharing this data with industry or other universities? So once we've kind of unpacked that, explained what we're talking about here, there's this question of what data? What am I actually publishing? And here it really does depend on the exact discipline. So whether you're sharing the kind of raw data, the clean data, kind of hundreds of terabytes of images or graphs, it really can depend. And then we have to remind them that it's it's not just that data itself, but it's also the metadata, the documentation that goes along with that data. So for example, if you have a survey data set, you also need to share the survey protocol and the data dictionaries if somebody's going to use that. We also often run into this issue of participant consent. So especially researchers that have been working with older consent forms, they often mention destroying data. And it's really hard to actually publish that data if you have agreed to destroy it. So going forward, most IRB offices are writing new consent forms that mention data sharing. But for those who have used these old forms, it sometimes means that they need to actually go and re-consent their participants. And then there's this question of de-identification. So I've got this data set, I did get permission maybe, what does it need to look like in order to share it? Sometimes people say, oh, do I just give it to the repository and they'll de-identify it for me? And that's just not generally the case. And especially when you work at a medical center like here at UCSF, where patient privacy is a really, really big issue, there's often a lot of reluctance to publish data that might potentially have a patient identifier in there on accident. And there's a whole question of qualitative data, which it's easier to get rid of those direct identifiers, but those indirect identifiers can be trickier to decide which ones to pull and figure out how to do that. And there's this question of where do you put it? So often when I talk with folks about data sharing, they say, oh yeah, I say anybody can have my data, they just need to send me an email. And then I remind them, okay, well, how easy is it to find your files from a year ago, 3 years ago, 10 years ago, and that we really recommend that they put it in a data repository where it can be managed. And we talk about how to find those with a tool like Fair Sharing or RE3 Data. But not everybody has a repository for their data. So especially folks that work with clinical data or other really sensitive types of data, there isn't always a domain repository or perhaps a managed access repository that fits their data set. So that can be challenging depending on the kind of research people are doing. And other folks just don't really see the value. There is sort of this feeling of ownership around data for researchers that have spent perhaps years and lots of money collecting it, and they don't really want to give it away for free. And here we have a conversation about how often their research has been publicly funded, generally by the National Institutes of Health, and actually technically belongs to the university, not them, and that they do actually need to make it public and follow those requirements. And at the end of the day, there's this question of time. Everyone wants to spend time on experiments, not on all of this other stuff. But the fact is that preparing a useful data set really does take time to find those correct files, add the metadata, curate it, find a repository and upload it. So what are libraries doing to kind of move the needle here? So first of all, we do a lot of training for current and future researchers. So several libraries now have kind of a data management program where we teach classes just in general through the library, as well as in the undergraduate and graduate curriculum. So here at UCSF, we have a responsible conduct of research series that's required for all graduate students and postdocs. So I teach one class on data management and sharing as part of that. And we also will come and meet with individual departments and talk about data sharing in their context. We also meet one-on-one with researchers to talk about data publishing and data sharing. I will go to labs and help them identify repositories for their data sets. Or we can refer to other groups on campus that are also involved in this area. And of course, curation. So Tumai talked about a really fabulous curation project there at Odom, and other libraries will often do that as well, where they will go through, they will check all the files, check for that README, make sure that everything is accessible. And of course, we provide data infrastructure and tools. So here at UCSF, we have a membership to Dryad, which is a kind of general data repository. Other libraries have actually built their own, or some are even developing tools for packaging data sets so that you can avoid some of those issues of having code that doesn't run, etc. And finally, we contribute to data policy. So both at the kind of national as well as local level, librarians have been involved with contributing to, for example, the recent National Institutes of Health released a draft of their data management and sharing plan. And many libraries, including mine, as well as the Medical Library Association and the Association of Academic Health Sciences Libraries, responded to that with ideas for how it could be, better, more effective. And then other libraries have actually worked with their local, schools or departments to draft data sharing and management policies. So how do we know if any of this is working? I would say, this is still very much the early days for many of this stuff. We just saw two very great examples of what this can look like. But I think for many researchers, it's still pretty early on. So we do try and measure metrics, of course. So looking at processes, are we being invited to present in more classes? Are we meeting with more researchers? Are we having more of these conversations? And then on the outcome side, are we seeing more folks depositing their data? Does that data look, better? Is it more documented? Overall, are researchers, sharing their data along with their articles more? And if we can, trying to get at that issue of measuring how reproducible is our research? Is this moving the needle on what that looks like? And overall, when I think of this, I really try and remember that my goal is always to nudge folks towards better, more reproducible data publishing practices in everything that we do. So that is all I have. Thank you so much.
Fantastic. Great job on the presentations, everyone. And thank you to folks who have already gone and added some questions to the Q&A section. If you have other questions, either now or as they come up during discussion, you can go ahead and put them in that QA section. And to get us started, I wanted to ask a question first to Tumai and then to Ian. So as you think about what data an author or researcher should share in this process, what is the level of data that you would like them to be contributing? So first to Tumai.
So for us, the HAPS has actually provided a very discrete list of things that they like to see. And I think it jives with what we'd like to see from a repository. And so what Ian had mentioned, it is important. It was very important for us to work together with them. But basically what we like to see is the data sets. So the data sets, also their code that is used to run the analysis and create the results that are reported. And that code, we like to see that to be well documented. One of the issues that we come across with code is that it's not well commented, or they forget things like loading packages because they're already loaded on their home computers, but that won't work on somebody else's computer. So software packages, and also using relative versus absolute file paths. So I think the problem is that a lot of researchers don't think about their materials in terms of reuse. So if they could imagine somebody else using it on an independent machine, I think maybe they would be better. Their materials might be a little better. The other thing we like is a README. So if they're using secondary data, they need a full citation to that, and also kind of listing what the files are and what they're supposed to be doing. So there's a lot of documentation, and a lot of people like to focus on the analysis part, executing the code, as the exciting part, but really the issues, a lot of times, it's the documentation. So if anybody can help me figure out how to speak to researchers about the importance of data dictionaries, code books, maybe there's a different word, we have not been able to crack that nut.
Interesting. And Ian, how about you? What should researchers be sharing?
Okay, so there's an interesting story to tell here about how attitudes have developed over time. So I think when people were depositing structures with us directly in the 90s, originally it was just the coordinates of the atomic coordinates that had been derived, and that was primarily it. But there's a lot of other layers of data that go into arriving at that result. And we have what we call process data, which allows someone to dig down much more detail to understand how the sort of final model was arrived at. And people weren't necessarily routinely depositing that, but there were some instances of fraud and also kind of like debate over whether or not people were drawing the right conclusions, which I think helped encourage both publishers and repositories to make a much more concerted effort to encourage researchers to deposit that data as well. What I would say, though, that really sort of like made this happen was the changes in the sort of software programs that are being used to analyze the data, which just started to spit this data out as routine. The current discussions that are going on focus around raw data, and they're perhaps a little bit more nuanced. Now, the challenge with raw data is that, in terms of, gigabytes of storage, these are much bigger than what we currently have to deal with, which are really small megabyte numbers at most for each data set. So the question is what's the value in doing this? Is it worth the storage? And there are reasons why storing raw data could be a good idea. It can help with methods development. If you develop your methods, then there's opportunities to reprocess the data and maybe get a better result. If this sample was maybe hard to synthesize, or maybe it doesn't last very long, this may be the only actual data set you get of that, or if it was the experiment was expensive to run. But I guess in small molecule crystallography, a lot of the work is routine, so I think it's very hard to make that argument because someone could just go away and regenerate the raw image if they needed it. In protein crystallography, I think there it's sort of some kind of like more advanced in sort of people coming up with solutions where the raw data is being stored in other facilities, but then sort of linked back to the data in the protein case in the protein data bank. And we've started sort of like doing that for some small molecule structures as well, where people have the raw data publicly available. We'll link from our database back to wherever that storage is.
That's great. So it sounds like certainly there are some domain level differences, but a lot of this is about making sure that it's documented and able to be reproducible. It sounds like across both of these fields. And Ariel, as a sort of a facilitator in this process, we heard a little bit of talk from Tumai about challenges of how to get people to comment appropriately or to give appropriate documentation on their tools. What do you think is an appropriate workflow? What's the ideal workflow that we should be trying to work towards?
Yeah, so I realize that none of us dropped the term data management plan, but that is a tool that I bring up as a way to really start thinking about these things at the very beginning of a research process. So ideally, when you're sitting down to write your grant, you're also thinking about what data am I gathering, where's it going to live, what associated metadata or documentation goes along with that data, and then where am I going to put it at the end. And so, that's something I've done in my own research, and I really encourage researchers to do. It's an extra step, and everyone doesn't want to do an extra step, but I think it can be a really useful kind of exercise and thinking in advance about, it's not just that survey, readout, that spreadsheet, it's actually the survey protocol as well, and crucially the data dictionary for that survey. So I think if people can kind of think in advance about that stuff, it really does help reduce some of those barriers.
Excellent. And we're getting some great questions coming in from the audience here, and a number of them have to do with what is the funding model currently for these data services? And Ian, can we start with you?
Certainly, yes. I mean, in the case of the Cambridge structural database, so when it was originally set up, there was some money from, I think, the UK government to help set it up, but very quickly that stopped being provided because they considered us to be becoming a mature service. So we had to look to other sources for that revenue. And the model today is very much based on the software tools that we develop and value-added services that we provide. So 70% of our revenue is, or around 70% of our revenue is coming from industry who are licensing that software or taking advantage of those services, with a similar sort of 30% coming from the academic sector in support of those sort of advanced tools. Doesn't mean to say that the data you have to sort of pay to get access to the data, because all the individual data sets and structures that are deposited with us are freely available for anyone to download on an individual basis. But yeah, that's a model that has served us quite well over the years, and it's not obviously one that's used in other places. And if I was to compare it with the Protein Data Bank, for example, their activities are kind of primarily supported by government grants from both the US and Europe. So within crystallography, there is actually quite a diverse set of different funding models in place.
That's excellent. Tumai, how about yours?
So for the work we're doing with the AJPS is hosted by the Midwest Political Science Association, and they pay for the services. So we have a model set up per manuscript fee, basically. That's based on how many hours that we perform. When we first did this, we didn't know how much it would cost, so we were definitely undercharging. But now that we know, we are basically recovering the costs of what we're doing. Now, there are other models for folks who do this kind of verification, maybe not directly for the journal, but the services are provided to the researchers directly. So I saw that Linda Kellum is online, but CISR, the Cornell Institute for Social and Economic Research, they have what they call an R2 or R3 service, RE3 service. I don't know, Linda, you can correct me. But so they provide that service directly to researchers. They come in, bring their materials, they work through and create a reproducible package. So there are a couple models, but for us, it's the journal basically that's paying for it.
Excellent. And there's a bit of a debate amongst the researchers that I've spoken to who are passionate about making sure that primary data is available. And oftentimes it's between whether this data should be a requirement for publication, or whether this should be the kind of thing that's encouraged, where there be some support for folks who choose to participate. Ariel, can I get your opinion on that?
Yeah, I think that's a really interesting question because honestly, I think if you ask most of the researchers on my campus, they would say it should be encouraged and then they wouldn't do it. And that's just, it comes down to this idea of, it does take time to do this and folks don't have any time. So I think if we really do want to, the places where I've seen that people are actually making time for it, they're writing into their grants, they're following through is when it is required. That is when people are kind of actually forced to take the time to do it and will come and chat with me and we'll have a conversation about it.
Either Ian or Tuma, do you have a thought on that too?
Yeah, I agree with that completely. And going through the literature also, the studies show that if the policy isn't stringent, if it's not strong, then people, no matter how much encouragement and resources, they're just not going to do it. Like Ariel said, because of the time and effort that's required. And also, but we also found that once people have gone through the process once, they're more likely to do it again. So if it takes a mandate for them to do it the first time, I think that will be the step forward to changing behavior to make this part of normative practice.
That's great. Speaking of the intensive nature of this on the author side, the researcher side, and also on the side of the reviewers doing this, the facilitation of this work, how scalable are these tools? Ian, do you have any thoughts on whether this can scale up to support our whole industry?
So, I mean, I guess in terms of volume of data that we deal with, we are dealing, I think, compared to a lot of repositories, at quite a high volume. But I mean, one of the things we have going in our favor is that the tools, the data is quite homogeneous. So we're not dealing with lots of different diverse types of data coming in. I think the other thing is that the tools we have developed have primarily been to optimize the process for crystallography. So unfortunately, we don't have a ready-made sort of like repository management system available that would necessarily easily translate to other domains. I think the situation might be a little bit different in the sort of more general data and institutional repository level, but I'm not as expert in that particular area.
Sure. Ariel or Tumai, any thoughts on that?
For our service, it's only scalable to the degree that journals are able to afford this. AJPS fortunately has the funding for this type of service. However, a lot of journals who have approached us aren't ready because of the costs involved. And that's why we have been doing more development. So somebody brought up or asked a question about containers. And containers is definitely one of the technologies that we're exploring to help facilitate this process. And other ways to link other tools, computing environments, Jupyter notebooks, things like that. Right now, I think it's going to be a lot for a lot of groups, not only the time, but also the expertise required to do this, the data curation and also the statisticians. So right now, it's a little tough, but I think it will be possible very soon.
Yeah, and I was just going to jump in to say, I think, what I see on campus is a lot of different disciplines within the health sciences having these conversations for the first time and really saying, what does our data need to look like? And when you get towards a point where you have more of those standards, like Ian was talking about with the crystallography, they have standards, the data should look like this. It's a lot easier to kind of point people towards that and say, this is what we're going towards. I work with, for example, people in our population health group who have interview data and they have these transcripts and they say, what format should these be in? And, it really does depend on kind of the discipline and having the discipline decide that together. So I can kind of try and, promote that, but until they have really decided as a discipline what it should look like, it can be kind of challenging to encourage it from the library side.
I'd like to add also to this, when it comes to scalability of these types of services, that we need the workforce, we need more folks in the workforce to do this work. I don't know about the others, but having done recruitment for data curators, it's tough. And so I'm hoping that more programs will focus on the tech part of information science and archiving and librarianship, to put more of that in there, more research data curation and more programming skills built into the curriculum.
So perhaps a skills vacuum here that needs to be developed. Are there other roadblocks that you think would stop this from being scaled up or rolled out to other organizations?
Right now, it's the cost and the expertise.
So if I can just add another perspective from the sort of longer history that we've had in crystallography, I think something we have had to take on, really pay attention to in the last 10 years or so is trying to automate processes as much as possible, because this is the other side of scalability. I think when you get to a certain point where there's a high volume coming, you can't, even if the people are out there, you can't necessarily afford to employ more people to do it. So making sure that you've got efficient ways of kind of actually processing, curating the data, and importantly triaging it actually, so that you know the areas where you need to pay most manual attention. That can become quite important as you scale up these operations.
That's a great point, Ian. I agree with that.
Excellent. And do you, both of you, have any suggestions for other organizations that might be looking either to find a partner to help them do validation or to start doing validation themselves? Where should they start that process?
I think we have been really thinking about the graduate curriculum. You know, a lot of them have statistics courses. A lot of them are talking about computational reproducibility, or starting to, I should say. So I think there could be, we hire a lot of students and they have told us the benefit that they have received from doing this kind of work. It's really complemented their research programs. So I think that's one place we can look at. Start with those departments, the departments there, and looking for champions, reproducibility champions who are believers in this process, and get their help recruiting people and also creating training and incorporating these things into the curriculum.
Other thoughts on that? Okay, in that case, as we start to think about more organizations getting involved here, what do you think, I know, Ariel, you spoke a bit to what success looks like in your working with students here. What do you think success looks like for the industry? What should we be moving towards?
Yeah, I mean, I think for me, it would be seeing more of these kind of data requirements, honestly, becoming a part of like every journal. So of course there's, you know, PLOS One was kind of the big one early on, the PLOS journals, and more journals have kind of taken that on as well. But, you know, often I have these conversations and people say, well, my journal doesn't require that, so I don't really need to pay attention. So I would just love to see, you know, kind of data sharing requirements across the board so that we can assume that this is part of the workflow that researchers will need to kind of work on, and it will just become a lot more part of kind of everybody's work and part of the practice.
That's great. Other thoughts? Maybe Ian?
Yeah, so I think sort of sketching out my vision for success, number one is that we don't have to discuss this, it just happens. But I think, you know, it's worth thinking about what's required to do that. I think general requirements are one thing there, and it's not just having the requirements, but it's also kind of monitoring to make sure that they are complied with, because that doesn't always happen. But in order to facilitate that, I think it's really important that you have the infrastructure that makes it easy for the researcher to do it, so they don't have to think about it and thus don't come along and say, well, do I really have to do that?
That's great. Tumai, any thoughts?
Yeah, I think that really is key. We can come up with all the tools that we want to, that we think can solve the problem, but we can't expect researchers to adopt yet another tool to do the things we'd like for them to do. So if we can build tools and build workflows and processes that become integral to their work, that don't feel like extra steps, I think that's going to be really important. But like Ian said, the ultimate goal is for this to be part of their normative practice, where they don't think about it, it's just what they do. And then also having the services available for them, which means we need more data-minded information specialists to help support the researchers throughout the life cycle.
Interesting. So I'm hearing, again, some of this tension between requirements and encouragement, where it sounds like, you know, we're looking forward to a time in which it may be required across the board, but that doesn't feel like a burden. It feels like kind of a natural step. So maybe there are some structures that we need to put in place as a community, as an industry, to make sure that the incentives are in the right place for people to be contributing their data during publication as well. Any thoughts on what types of incentives might be possible there?
So I was actually thinking about this, but more from a university perspective. I think that one really strong incentive to faculty especially is the tenure and promotion process. And if we can write these things into, into that process as having more value. And, I have this grand open science vision where it's not just that at the end of 5 years of research, you write one article, you have perhaps released, 10 data sets along the way. Each one of those has a DOI, you get credit for those. Maybe you made your protocols available, you also get credit for those. Maybe you published your article open access. There's just, I think, a lot of different ways we can kind of build in credit for the work that people do. And if that was really a strong part of the tenure and promotion packages and faculty saw that that was valued and they got credit for it, I think that would be a lot more convincing.
That's great. Any other thoughts there? Well, Tuma, you had mentioned the need to scale up our support as well, and it sounds like you're talking about people kind of like Ariel. We also had a question come in from the audience. What kind of skills does a librarian or another facilitator need to help researchers to be able to coordinate their data and get it ready for publication?
Well, I feel like I've been thinking about this quite a bit lately. We're developing these training modules for information scientists, for librarians, archivists, and we're also developing training for researchers. And it seems that based on sort of environmental scan of different research programs, they're shooting for the same thing, but they're not speaking the same language. I think one thing that's important for a librarian is to learn the language of researchers. It doesn't mean you have to know how to run a regression, but you do have to have a sense of what that research workflow looks like, and not to think as data as a discrete object, but as an artifact of a larger process. And I think if we approach data that way, I think it opens up our eyes to a lot of the idiosyncrasies of data, the challenges that researchers go to. So speaking their language, understanding their frustrations and respecting those because they are busy people, and just getting a sense of how data work and some of the pitfalls of working with data, but definitely going beyond the idea of data as discrete digital objects. I think that's one thing that I found really important in this work.
Great. Ariel, do you have any thoughts from the trenches?
Yeah, I totally agree with Tumai on this. I think that librarians need to understand the research process, how research works, ideally they're doing their own research so they can understand it firsthand. And so I think understanding that research process, but also, more and more of the research that is being produced, especially where I am in the biomedical sciences, is more computationally intensive. So being able to talk to those workflows, to understand those processes. I don't think you need to be able to, write a really intense Python script and pull something from the cloud, but to understand, what are the tools people are using, and getting training. I think Tumai mentioned the carpentry, so library carpentry is a great place for librarians who are interested in just having more of that kind of data literacy so that they can chat with folks and help them do this work a little bit better.
Great. And we talked a bit about what success looks like in the industry, but curiously, we didn't talk too much about researchers accessing the content after it's been published. And one of our attendees was asking, so for you who are working directly with the data, how often do you think this data is being accessed? Do we have data to help back that up?
Well, we haven't run our numbers yet. I mean, there's some literature that says if you cite, if you share the data, then at least the manuscript or the article is cited more often. We haven't done that yet. So, but we will be taking a look at that. It's just hard to compare, pre-policy, post-policy with different articles, depending on what's hot in the research field at that point. But I think that is an important question. For us, all the data have to be shared for AJPS. There are very few exceptions for that. And we keep the data in our repository in perpetuity. So at some point, we'll get some data on that.
Ian, are you doing any tracking of the access to the content?
Yeah, so I mean, we have web-based services where we can sort of look at number of page views and visits and things like that. And yeah, I think something that we're kind of mindful of is the kind of what we can sort of what is right to say publicly about this sort of thing. And I think this touches on, you know, a topic which is very much actively under discussion in the wider community. It's how do you reliably report things like page views and downloads such that you can actually meaningfully interpret them, and what are the caveats on those numbers. CCDC has a particular challenge with this because, you know, some of our software products are desktop-based products that people are installing in their own institutions behind company firewalls. We just don't know what people are doing with the data. I'd like to think that people are using it every day in industry, but it's very hard to sort of like gather the evidence that says that. We have actually started adding telemetry to our software as well, so people can opt in to sort of letting us know which features we use. So that starts to tell things, but of course we have to be a little bit mindful of sort of privacy and you know, data protection concerns. So there's lots of ways that you can answer that question. I think they're always going to be a little bit caveated. I think one of the ones we fall back on is periodically looking at where the overall resource has been cited in the sort of open literature, just to sort of perhaps demonstrate the value of actually the collection of data as much as the individual data sets.
Great. Ariel, do you have any thoughts on your efforts putting in, or are people making the best use of this content?
Yeah, I think it is a really interesting question. And as Ian mentioned, there is a difficulty in kind of counting how data is being used. There's a project called Make Data Count that's trying to come up with more standardized ways of, you know, counting downloads and access. So we look at how often things are downloaded, we look at how they're accessed, but, you know, at this point, I'm always trying to think in terms of small steps, and my baby steps are first get people to understand this is a thing that they can do, is to publish their data, then maybe get them to put it in there, and then maybe get them to think about how can I do it better next time so it's more, you know, usable or better for others. So, you know, we're always kind of trying to push them a little further along. And I think, you know, being able to really measure reuse is a key part of that.
And along with that, the data citation, getting people to cite data just as they would another article or a book, that we want to see those things in reference lists, and that will make it a lot easier for us to count some of these things.
Yeah, definitely.
Excellent point. And I think that is an excellent point for us to take a break as well. So I want to thank all of you for your participation today, and I'm going to hand back over to Leah for a few more notes.
Thank you. Let me throw up a closing slide here real quick. I would like to echo that thanks sincerely to Jeff and Ariel and Ian, and to Mai. Thank you so much for putting together a fantastic presentation. I learned a lot, and I hope our audience did as well. I want to say that the recording and the slides will be posted soon, and we'll send out an email to everyone who registered for the session with a link to that once it's available. And we will also have a very short, like 3-question attendee evaluation when the webinar closes. So please take a few moments to let us know your feedback and give us some comments on today's session. We also hope that we will see you at the next Cooperative SSP Charleston event. If you're attending UKSG in Brighton, there's going to be a pre-conference that is hosted by Society for Scholarly Publishing and sponsored by the Charleston Conference. It's called Seeking Sustainability, Publishing Models for an Open Access Age. So check that out if you're attending UKSG. You can find information on SSP's website. And other than that, we hope that you had a good time today and that you learned a lot, and we'll see you back at the next Charleston Conference webinar. So thanks everyone. Have a good day. Bye.